In this particular question, we're told that a car leaves town A at 3 p.m. and travels due north at 60 kilometers per hour. Another car is heading towards town A from the east at 80 kilometers an hour and reaches the town by 4:30. We're asked at what time were the cars closest together. Let's start by drawing a series of diagrams to make sure we understand the question. What you'll notice in the first little diagram is I've just got my first car heading north. It hasn't gone very far, and my car that's coming from the east is quite a ways away from town A. So you'll notice that I've drawn the hypotenuse, or the distance between the two cars, in with a dotted line, and you can see that that distance is quite large. Then what I've done is, in the next diagram, is the car that's heading north has traveled a little further, and the car that is heading from the east towards town A, well, that distance is now shortening, and again I've drawn in the distance between the two with a dotted line, which actually represents the hypotenuse of a right-angled triangle. And then I've drawn a third diagram where I've shown that the first car is headed a considerable distance north of the town A, while the second car is getting pretty close to town A now when it heads from the east. And you can see that I've drawn its hypotenuse in as a dotted line, or the distance between the two vehicles as a dotted line. So what's obvious is that we're dealing with a right-angled triangle. So I've drawn my right-angled triangle and I've labeled my sides A, B, and C, where C is the hypotenuse. Now what we're trying to do in this question is we're trying to minimize that hypotenuse because we want to see at what time the two cars are closest together. So I start with the formula that relates those three sides, which is the Pythagorean theorem. C squared is equal to A squared plus B squared. Rearranging or solving for C in terms of A and B, I would merely take the square root. So I end up with C is equal to the square root of A squared plus B squared. Now, you end up with two problems at this point in time. First of all, that we have three variables, C, A, and B. And none of those variables seem to have anything to do with time because we're trying to determine at what time were the cars closest together. So what we have to do is think back to a little bit of physics that we know. We know that distance is equal to speed times time, or probably a better term if you're doing physics is velocity is equal to, displacement is equal to velocity times time. Well, if we take that into account, the distance for side A is going to be found by taking the speed or velocity, 60 kilometers per hour, and multiplying it by the time after 3 o'clock. So A is going to be equal to 60t. And most kids don't have a problem understanding that. B is a little more difficult to figure out. A lot of kids just want to say that B is equal to 80t because they say, well, the speed is 80 kilometers per hour and we're multiplying it by the time. But remember that that side or leg of the triangle is actually getting smaller. Remember that the car took an hour and a half to reach town A. So that means at 3 o'clock that car must have been 120 kilometers away from town A. So keeping that in mind, B would have to be equal to 120 minus 80t. So now we've got A and B expressed in terms of t. We can return to our other equation and substitute in these values for A and B. So C is going to be equal to the square root of, instead of A squared, 60t all squared, and add to that B squared. In this case, B is equal to 120 minus 80t, so that's all squared. I'm going to expand that, and I've also, instead of writing it as a square root, I've raised it to the exponent 1/2. So C is going to be equal to 3,600t squared plus 14,400 minus 19,200t plus 6,400t squared, and all of that is raised to the 1/2. All I've done in my next line is combined my two like terms, and now I'm ready to take the derivative, c prime. To do this, I have to use the chain rule. So c prime is going to be equal to 1/2 times, in brackets, 10,000 t squared minus 19,200t plus 14,400, and all of that is raised to the negative 1/2, times 20,000 t minus 19,200. Now we want to take that derivative, c prime, and set it equal to 0. And I've also taken that derivative and written it in slightly different form. So 0 is equal to 20,000 t minus 19,200, and that's all being divided by 2 times 10,000 t squared minus 19,200t plus 14,400, all raised to the 1/2.